Hello and welcome to my channel, and the channel name is VLSI Design, and I am SSG. So let's start our journey uh, of learning VLSI. I know many people find VLSI to be tough, to be boring, to be not so cool, but it is cool. I mean, even I also felt that VLSI is kind of boring, too much technicalities, and made no sense when I was doing my BTech. And to be very honest, it was my friends who helped me get through this. Uh, they taught me VLSI just before the exams. You know how it is during the semesters. So it was my friend who taught me VLSI just before the night of the exam, the eve of our exams, and somehow I cleared it. And I used to think that, oh, thank God it's over now, I don't have to deal with it. But destiny took a different turn, and then I started off my journey of doing MTech, and the specialization was VLSI and embedded systems. So the very friends who taught me VLSI one night before the exams, they started laughing and guffawing that how did you land in this soup? I mean, what was your process? And I said, I don't know. Let's see. Let's see what I can do. And they were dead sure that I'm gonna flunk it. But no, I didn't. And the reason behind that journey was my faculty who taught me VLSI design in my first sem of MTech, and she made it interesting, and she actually made me love VLSI for what VLSI is. And it was the same textbook that we used to follow in our BTech and in MTech. So I'm a fellow graduate of BPUT, that is Odisha State University, that is Biju Patnaik University of Technology. And we used to follow, I think the author name was Kang. I don't even remember the full name, but it's some off-white color cover. And yeah, it was the same book, same VLSI, same font, same equations, but the difference was my faculty, my professor, who also happened to be my HOD. So yeah, she made sense. I understood whatever I couldn't back in BTech. So yeah, so I still know many people just scram through this paper during their bachelor's. They're very scared of this paper, and I'm here to help change that narrative that VLSI is cool, VLSI is easy, and without VLSI, there wouldn't have been any kind of future that we are living in. All the smart wearables, all our tablets, and smartphones, everything is because of VLSI. So yeah, let's start our journey, and we'll start with our lecture 1. I know this sounds and looks very formal, like lecture 1 VLSI design, and the date is also there in front of us. So let's not judge it before we even start the journey. Although it looks familiar, let's not judge it by the font of it. Let's judge it by the end of the course, wherein I'm damn sure that you will be able to understand all the things. And if you have any doubts, you can obviously put your doubts in the comment section. I'll be more than happy to help resolve those doubts. And yeah, with on that note, let's just start our journey. Yeah, so okay, now we can see, so in my screen you can see that I have written some things right at the top of my screen, and one of those things is the name of the course, that is VLSI design. Now in your university or whatever you're following, like you may be a part of a different university where the name of the subject might be different. uh, it could be named anything, VLSI something something, but the crux of the course will remain the same, that is VLSI. All right, so I made that clear. First things first. So there are two words here, VLSI and VLSI design. Like the second part is design, right? So there are two things. So first things first, we have to understand what is VLSI. That is our first point, that what the hell is even VLSI, right? And the second thing, like by the end of our course, now I'm talking not just the first lecture, I'm talking about the whole syllabus here. So by the end of our syllabus, you will be able to understand what this design means, right? So now this design is related to VLSI. Now design, what do you understand by the word design? Means we are designing something, right? I mean, you must be thinking, wow, what an explanation. What is a transformer? It transforms, right? Famous Viva question and a famous Viva answer in India. So yeah, I'm not just saying that, I'm going to explain myself over here. So whenever we think of design, so mostly it is related, like mostly we know something, either we are creating a new device or we are creating a new sketch. If you are into fashion designing or one of your friends is in fashion designing, and you kind of envy her or him that, oh my god, she or he got to follow their dreams of doing something apart from engineering, right? Let us not envy them. So design over here would mean that you're creating something. It could be anything, okay? You could be a civil engineer, all right? You know someone who's into civil engineering, or you know someone who's into architecture, or you know someone who's into research of multiple fields. Like someone may be a researcher at medical, or someone might be a researcher at pharmaceuticals, where they invent new pharmaceutical drugs, right? So that is what we mean here by design. That means we are creating something. Now when we relate this creating with the word VLSI, so what are we gonna do? Throughout the whole syllabus, first we are going to learn what is VLSI, we're going to understand what is VLSI, and then by the end of the course we'll be having a much clearer understanding of designing something out of VLSI. Okay, now let us not take the pressure of, oh my god, we have to design. No, that is not mandatory. It's just that the basic minimum over here is I'll help you out in clearing your paper, right? Whether you have a backlog with VLSI, or it's the new paper that you are dreading, oh my god, I don't want to study this, just take it away from me. But if you are an electronics and communication engineering student, or you are doing your masters in ECE, VLSI is a paper, and you are stuck with VLSI, then you got to understand the basics of VLSI, and you need to learn how you will design it, right? So these are the two words. So the whole course revolves around two words, VLSI and design. So we will start with understanding VLSI, and by the end of the course we will be eligible, or at least we will be able to understand, okay, how this design will work. All right, so this is an introductory class. All right, so don't take so much of pressure that, oh my god, equations are gonna come right now and all that. No, this is the preliminary class, and trust me, you will get you will understand what I'm talking about by the end of this session, right? So let us start with VLSI. Now what is VLSI? Whenever somebody like when we started our VLSI class, so our professor asked us, what is VLSI? And one of the toppers, the topper syndrome, he or she would raise their hand and blurt out, blurting. It's not even answering the faculty, it's blurting out the full form, right? So what is the full form? So let us follow the topper's syndrome, that is VLSI. What is the full form? Very large scale integration. Okay, so this is the full form of this term VLSI. So we have got V, L, S and I. Very straightforward, right? But when you blurt out the full form, whenever somebody asks you what is VLSI, and it is our human tendency to answer that particular question with the full form of it. If it's an abbreviated form, then that is our human tendency of blurting out the full form. But do you even understand what this full form means? Do you even understand that, right? So the way to answer this question would be like anybody who whenever they ask you what is VLSI, since you will be a graduate of electronics and communication engineering, so anybody might ask you, like, you have this paper, what do you understand by the term VLSI? And at that point, if you answer it with the full form, it doesn't really look good on you. So even if you're a topper or you're a backbencher or you're somewhere in between, like you're neither a topper and nor a backbencher, and all of you all give the same answer, it doesn't really look good on you. So first things first, you need to understand what this is. Full form will come later on. Okay, so the full form weightage as an answer is very less. You need to answer what do you understand by this. All right, so now let us understand what is VLSI, how to answer this question. So what would be VLSI? Now, while I was introducing myself and before starting this session, I was talking about how without VLSI, there wouldn't have been this future that we are living in, right? All the smartphones, smart wearables, like the smart watches or the smart rings that we have, right? And whatever you are accessing on the internet, or you are since you are in, let's suppose you are in BTech, so you are already crazy about the project. So my god, new terms should be there in my project. My project name should have automation as a term in my title, or there should be a smart design, smart word should be there, or Internet of Things word should be there, right? IoT and all, isn't it? So all those things wouldn't have been possible without VLSI. This is what I had told you, right? Now other department fellows might argue, oh, without electricity anything would not have been possible. Then without the mechanical things nothing would have been possible. Then the early age men would come and argue, like, without us, if we hadn't discovered fire, if we hadn't done all the things with the rocks and the wheels, right? So nothing would have been possible, right? So for argument's sake, many people will say many things, but if you do not have a gadget that can handle all these activities that we are doing, everything is on portable devices, right? At the beginning, like if you have some elder siblings or you have some relatives who are cool, okay, not just a little bit elder than you, and they're cool, so you take them as your idols, right? So they would say that earlier we used to have desktops, now we have laptops, now we have MacBooks, now we have our smartphones, now we have our iPhones, and then we have our smart gadgets and everything, right? So we are constantly connected over internet, isn't it? So since we are ECE people, for us VLSI is the base. Okay, now why did I say that? Like, why without VLSI there wouldn't have been this future that we are living in. Okay, now when we try to understand the statement, that means what? That means that VLSI is nothing but a technology. Okay, it is a technology. What does this technology do? Now if I say if you ask me, SSG, what is VLSI, right? And I say, it's a technology, to sound cool and all, I'll say it's a technology. And then you might ask, and what does this technology do, right? So what is this technology and what does it do? It integrates millions and millions of transistors. All right, so we are acclimatized with the term transistors, right? And other electrical components over a smaller area. Okay, so what is VLSI? VLSI is a technology. Okay, it's a technology. And what does this technology do? It integrates millions and millions of transistors and other electrical components over a smaller area. Okay, now there are several keywords in this statement. Okay, so the first keyword is that it is a technology. What does this technology do? It integrates, right? And if you would have noticed that the keyword over here is integrates, and in the full form as well, the last letter, that is I, that is also integration. Now when we talk about this integration or integrates, right, we'll come back to this statement a bit later. First, let us understand what we are talking about when we talk, when we see this word integration or integrates in VLSI. Okay, what is this integration? The first thing that will come to your brain is, that is the mathematics thing, man, right? Wrong. This is not the mathematical integration that we have learned over the period of time while growing up in our schools, right? This is not that. That is a different thing. This is a different thing. Okay, now let's say, so this is I'm starting my journey on YouTube, right? So I am trying to share my knowledge over YouTube. Now, do I have control over who watches my video, this educational video? No, right? There could be a girl from Assam, there could be a girl from Gujarat, there could be a boy from Uttar Pradesh, there could be a boy from Tamil Nadu. Because anybody who's on YouTube and wants to dreadfully understand what is VLSI, let's suppose in his or her algorithm my educational video pops up, right? So at that moment they'll be able to understand what I'm talking about. So what is happening over here? Now see, why am I giving this example? So let's suppose this is me, okay, and I'm teaching on my tablet, right? This is my tablet. Now please don't judge that I'm not drawing my hands and legs. Just think of me like that. Okay, I'm really not that great at drawing. So this is me, okay. This is me and I am SSG. So you are joining my journey of learning VLSI design with SSG. Okay, so now I am uploading my first video. Okay, first lecture. Now let's suppose there is this guy from Tamil Nadu, there is this guy from Uttar Pradesh, there is this girl from Assam, there is this girl from Gujarat. Okay, and somehow they all are trying to understand VLSI, and in their algorithm I come up. Okay, so what has happened over here, and this is via YouTube. Okay, so what has happened? So YouTube is a platform which is bringing people closer, isn't it? Like I am somewhere in India, I'm not going to disclose my location. Okay, so I am somewhere in India and I am uploading my knowledge. Okay, and you are somewhere in India or beyond India, wherever you might be, and you want to learn VLSI, and my video pops up, so you are able to access my knowledge via YouTube. Okay, so what has this platform done? It has brought in, so let's suppose this is me, I am teaching, and these are the people who are accessing my video, right? So all these 5 people have come together in a smaller area. Not everybody is going to learn VLSI, isn't it? Not everybody is in EC, not everybody has a back in VLSI or is the current paper in VLSI, and they are not able to make head or tails about this subject, right? So this is a smaller area. And what has this platform done? It has brought all of us together. Okay, now whenever anybody brings in different kinds of people in a smaller area, or let's take your classroom for example. So in your classroom, are all the people from the same locality? No, right? Some may be hostelites, some may be day scholars, isn't it? And from the hostelites also, someone may be from Jharkhand, someone may be from Manipur, someone may be from Odisha, and the locality might be Bangalore, right? So in that classroom, okay, and the teacher might be from, let's suppose he or she is from Maharashtra. So not everybody is the same, isn't it? So what is happening? Your classroom is also a smaller area, and your college has brought up this. College is your platform, and it is bringing the people who want to do the same thing, that is learn and share knowledge. Okay, so this bringing of different things together is called what? Integration. Okay, so this bringing of different components. Now the example was of humans, but we are not going to study about humans, right? So we're going to study about who? VLSI. So in VLSI, of course, we'll be dealing with transistors and other electrical components. And what is VLSI doing? It's a technology via which we can integrate millions and millions of transistors and other electrical components over a smaller area. So now, is the statement clear to you? So whenever somebody asks what is VLSI, so you have to explain it, okay, and then maybe give the full form, over here, right? So this is the first thing that I wanted to make clear. Okay, so this is what is VLSI. Now, so from this full form, you might have noticed that I have only covered the one alphabet of the abbreviation, that is the I. Okay, now if I look at all the 4 letters of this abbreviation, that is V, L, S, and then I. So we have covered I. Okay, now very and large. Okay, so very is a verb. Okay, so that is completely English. Okay, so we'll come to it later on. Then comes the word large. So large means what? Large means more. So over here the context would be what? That earlier maybe earlier maybe the quantity would be, let's suppose, 1 kg, and now the quantity is 5 kg. So this has become large. Okay, let's suppose you are into your MTech, okay, and you're staying outside your university and you are cooking for yourself. All right, so first of all you brought 1 kg of rice, then you saw it got over very quickly, so next time you brought 5 kg of rice. So relatively the quantity became large. Okay, so these are English words. Okay, there's nothing more to understand over here. That's what I'm trying to point. So the question is, what is this scale? What is this scale? Now you would argue, array SSG. Now you already said very and large are English term. Scale is also an English term. No, we are learning everything in English. You are also speaking in English, right? But sadly, no. This term is of utmost importance and you need to understand the significance of this word. Okay? So now, scale. Whenever we hear this term scale, the first thing what will come to our mind, is it a ruler? Or is it like when I was in school and we were learning geography, and there was this topic of topographical survey maps, right? So in that also we came around the term scale. Even if you didn't cover this topographical survey maps, don't worry, you might see in some atlases or some maps that there at the corner of that map there will be written scaled to this. Okay, so like the whole, if I want to print the whole world in one single piece of paper, so of course I am going to scale it accordingly, right? So is this scale the geographical scale? Or is it something else completely, like the scales of fish? So if you are coastal people and non-vegetarian, you would know what is fish scales, right? So what is the scale in VLSI? Now you would also think, I mean, come on SSG, these three options are blatantly wrong on so many levels that we can also say from the screen that no, these all options are wrong and you're just triggering us, right? So yeah, you guys are right, none of the options are correct for this scale in VLSI. So what is this scale? Okay, now to understand this scale, let me bring in a topic that mostly all of you would be able to relate. I hope so. So a few years back, like the Marvel movies were kind of trending. So all the movies were great. People used to relate with their superheroes, and there used to be like somebody likes Captain America, so somebody would like Iron Man, somebody would like Hulk, somebody would like Loki after the Loki web series. Right now they are going through a slump mostly. So let me bring in the example of Marvel comics. Okay, don't worry, I'm not straying off topic. Okay, so let me bring in the example of Ant-Man versus Hulk. Now you must be thinking, what is happening? Ant-Man versus Hulk. Of course Hulk will win, right? Do you think Hulk will win? or do you think Ant-Man will win? Now, if I'm not wrong, either the movie was Ant-Man or Civil War, wherein the Avengers broke into two factions. Like one was siding with Iron Man, the other was siding with Captain America. Right? Why that happened, I have forgotten. Okay, so I think there was a scene wherein Ant-Man was fighting Hulk. Okay, so we would obviously think, come on, man, Hulk is like Hulk only, no? He will smash. He will scream and he will say Hulk smash and smashes people, right? But Hulk will not win. Okay? Now, Hulk fans might get angry. Okay, what you're telling, huh? But why am I saying so? I'm saying Ant-Man will win in this. Okay? And those who are not watching Marvel movies or DC movies, superhero movies and all these things, right? Or Harry Potter and all. So, can't say about the Harry Potter or Lord of the Rings people, but for the people who are watching Ant-Man, the movie is not bogus. Now you would think, what, the man is reducing in size and gaining all the powers, or man is becoming too big and gaining some kind of powers. Is that how a superhero should work? No, right? Either it's a super soldier serum, or it's a god of thunder himself, Thor, isn't it? But by science, the superhero concept of Ant-Man is actually true. That is the most scientific any superhero might get. That is actually the scientific thing, not the Spider-Man bite. You will die if a spider bites you. Okay, so why am I saying that Ant-Man movie is scientifically based? You might be laughing at me right now. So let's see. Let's talk about some ants. Okay, now ants somewhat look like this. The big one, okay, not the small ones. Even small ones, like I don't know how to draw them, so I'm drawing this. But the big one, the red one, the small black one, or the small red one, okay, all the ants, I'm covering all of them. No discrepancy over here, no discrimination over here. Okay, now why am I saying that Ant-Man is the most scientifically correct superhero? Okay, why? Because the scientists did an experiment on ants. They observed them. Okay, what is happening with the ants? What are they doing? So mostly when we see the ants, they are forming a line and moving somewhere to somewhere. Okay, and let's suppose you are making tea, or you are making coffee, whatever may be your preference. And let's suppose you are on the sweeter side of the spectrum and you drop little sugar on your kitchen slab. Okay, one granule only. So let's suppose the granule is here, and before this sugar granule drop, there was no scene of any ants. But within half an hour or 1 hour, you will see tiny ants forming a chain appear near the sugar granule. Okay, now you also might have seen, let's suppose you're eating some chips, some cakes, some pastries, and you called your friends to your home. It's a birthday party, and some food left over might have fallen down while eating. Okay, and it's just on the floor, and before you could even look at it and sweep it away, the ants have arrived. Okay, now for that tiny ant, this sugar granule is also too big, isn't it? For this tiny ant, the piece of cake that has fallen down from your friend's lap is also too big. So that is also getting carried by the ant. And if it is too big, then 2 or 3 ants together, they will carry it. You have seen this in your real life. Okay, so such a tiny body, such a tiny body. The smaller ants look like this, 2 dots only, right? So how is it possible that such a tiny organism carrying such a big thing on their backs? How is it possible? And how are they able to figure out where their food is? Before this leftover food, there was no scene of the ants, right? You're a very clean, neat and tidy person. You keep your kitchen clean, you keep your house clean. Your parents are not scolding you for being untidy, right? So how are they able to track these things? And why is so much discipline in their tribe? Everyone is following the other, right? That is because the scientists, after observing and experimenting with the ants, they found out that ants are actually having 10 times the strength compared to their body. So their body might be tiny, but whatever the body size that they have, this tiny ant or this big ant, whatever may be the size of their body, 10 times that is their strength. 10 times that is their strength. And they actually have good sensing capabilities. So because of this observation, the scientists thought, okay, such tiny thing with so much power, can we implement this in our technical field, right? So they concluded that if we reduce the dimension of our devices, they would naturally become powerful with some limitations. Okay, that will come later on within this course only, so don't worry. I will again, when the right topic will come, I will again discuss the ants. So don't forget this topic of Ant-Man versus Hulk. Okay, so this was the conclusion from their observation. So if the dimension of a device is reduced, that device will become powerful. Okay, so over here, so if you have not forgotten, I started off with the word scale. Okay, so scaling means what? Scaling means, now scaling could be anything, na? Like in the movie itself, you saw Ant-Man reducing in size, super speed, isn't it? And if it is increasing in size, then of course it was a con for him. He was not able to generate that much energy to fight after that, so he had to reduce his dimension again. So scaling means it can be scaled up or down. Reducing the dimension means scaling down, and increasing the dimension means scaling up. Okay, so in VLSI, just guess which one we will be following, up or down? We will be following scaling down. So in VLSI, we will always go for scaling down. Why? Why this mandatory thing? I should be free. I should choose, right? Up or down, scaling up or scaling down. But why is it that we are making it mandatory to scaling down. Why not scaling up? Because if you remember the statement of what is VLSI, what did I write? Millions and millions of transistors and other electrical components over a smaller area. So if I have a smaller area and I need, let's suppose this is my smaller area, and within this I have to fit in 1 million transistors and other electrical components, will I be able to do with larger devices within it? No. I have to use smaller devices so that I can fit in more of them, isn't it? So this is what scaling is, and in VLSI why we are only going for scaling down, that logic also I have given. Okay, so now I am ending the first lecture over here. Okay, I hope you have understood the concept. So today I didn't cover much. It was just what is VLSI, and we just decoded the full form, understood what actually is VLSI over here. And in our next session we will be covering from this point. Okay, I hope you enjoyed this lecture, and we'll meet soon. Please do support me. Please drop a like. Please subscribe my channel, that is VLSI Design. I'll try to make things easy for you. Yeah, please do support me. Thank you. That's it. Enjoy your life.